Good day, everyone. You are welcome to my charge. In today's class, our subject is physics, and we'll be treating electric charges. I am Giwa Alim Kende. Lesson objective. At the end of the lesson, you should be able to explain the concept of electric charge, illustrate practically the effects of triboelectric charges, and lastly, state Coulombs law and apply its concepts. Topic outline. In the class today, the following are what we'll be looking at and explaining. Electric charges. Number 2, triboelectric effect, insulators and conductors. And lastly, Coulomb's law. What is electric charge? Electric charge is the physical property of the matter that causes it to experience a force when placed in an electromagnetic field. Note two words here, force and electromagnetic field. What causes a property to experience a force, and why are they placed in an electromagnetic field? The diagram above should be a little bit of curiosity to you. Why do we have lightning, and why are bulbs on here? What is responsible for all these bulbs light up in this city or environment? I will leave you to answer the question as we proceed with different discussion and explanation on electric charges. Stay attentive. There are two types of charges, namely 1. Negatively charged and 2. Positive charge. The charges are carried by proton and electron respectively. Going to elementary knowledge about atom consists of 3 subparticles, namely electron, protons, and neutron. Electrons are negatively charged, protons are always positively charged, and your neutron is neutral. Having understood this, then we'll be able to extend our knowledge. An object with more electrons than protons is said to carry a negative charge, and an object with more protons than electrons is said to carry a positive charge. Don't forget, we've said earlier, electrons carry negative charge and proton carries positive charge. Good. When an object has an imbalance in the number of electrons and protons, it is electrically charged. If proton is more than electron, your body will be electrically charged. And also, if proton is more than electron, the body is said to be electrically charged. Objects normally contain equal numbers of electrons and protons. Such objects are called neutron. The diagram below have explained the fact that charges here are balanced because we have the same number of protons or positive charge and negative charge, and such object is said to be neutral. Triboelectric effect. What do we understand by triboelectric effect? Why do we need to understand what is meant by triboelectric effect? The definition should give an insight to that. Triboelectric effect, also known as triboelectric charging, is a type of contact electrification on which certain materials become electrically charged after they are separated from a different material with which they were in contact. Two bodies having contact with each other have already attracted their charges. One might be positive, one might be negative, but there will be distribution of charges between them. Immediately they are separated, these charges are excited, already waiting for another body to get attracted to. That is, opposite charges of another object to be attracted to the other charges of the normal body. And this is the bedrock or basis for what we know as static charge or static electricity. Yes, I mean static electricity or static charge. What do we understand by that? A good illustration could give you an insight to what we know or understood by static electricity. Have you ever wondered during Harmattan period when you lay the bed and you want to sleep on it, you experience some shock? Have you tried to inquire why do you experience such shock? Were you scared? Okay, don't worry, today you're able to know why you experience such shock and you won't be scared no longer. The reason is simple. The bodies are in charges. Looking at those diagrams, a rod and some pieces of metals are brought to come in contact, but there is no charges. Immediately the rod is rubbed on a foot or on here. It has excited the charges because triboelectric effect have occurred, separating them and bringing it closer to the small pieces of metal got attracted to the opposite charges in the metal. then you experience a shock. This is basically what happens when you lay the bed or dusty bed and you try to sleep on them, experiencing some shock. That is just it. You experience what we know as static electricity. Now I'm very sure you won't be scared next time. Okay, let's proceed with our class. Quantization of electric charges. If a system contains 2 points, charge 1 and point 2, don't forget, either positive or negative, having 2 charges we are dealing with, then we can determine their net charge by simply adding the charges together. Take an example of this. The total charge of a system containing 5 charges, 1, 2, minus 3. When added together, 1 plus 2 plus minus 3 plus minus 2, the net charge is minus 2. Definitely, such a system is said to be negatively charged. But if our net charge is positive, we are going to say the body or the system is positively charged. Also, electric charge is quantized in unit of E. The atom that has gained an electron is negatively charged and it is a negative ion. The electric charge Q is said to be quantized, and Q is the standard symbol for charges as a variable electric charge exists as discrete packets. Insulators and conductors. What do we mean by them? An insulator is a material whose conduction electrons are free to move throughout. Most metals are conductors: copper, aluminum, and zinc. Yes, your electron will move freely in a conductor such as copper, aluminum, and zinc. Don't forget, in our elementary knowledge, we are made to realize conductors allow the passage of current or heat. Insulator is a material whose electron moves from atom to atom. That is, they do not allow free move of electron to pass through them. Most insulators are metals. Examples are glass, wood, and some other materials like that. Coulombs law. Coulombs law states that like charges repel and unlike charges attract, with a force proportional to the product of the charges and inversely proportional to the square of the distance between them. The formula F equals to K absolute Q1, Q2, that is the charges, all over R square, and the SI unit is Newton, capital N, and the definition of terms, F is the force of electric charge attraction, and it can also be force of electric repulsion. K is the Coulomb constant. Q1 and Q2 are the charges, either positive or negative, and R is the distance of separation or distance apart between the two charges. Work example. A charge of 5.67 times 10 raised to power minus 18 coulomb is placed 3.5 times 10 raised to power minus 6 meter away from another charge of minus 3.5 times 10 raised to power minus 19 coulomb. What is the force of attraction between them? Take your Coulomb constant to be equals to 9 times 0 times 10 raised to power 9 Newton per meter square per coulomb. As a physics student, when you want to solve questions, the first thing is to write the given data. This will guide you to solve your work easily. And this is my own given data from the question I was given. Sorry? Okay. F equals to K Q1 Q2 all over R square. Equating my given data, I have the following answer to be 1.58 times 10 raised to power 9 Newton. Summary of what we've done so far. Electric charge is the physical property of matter that causes it to experience a force when placed in electromagnetic field. There are positive and negative charges. Triboelectric effect is also known as triboelectric charging. Insulators allows electrons to move from atom to atom, and conductors allow free flow of electrons throughout the material. Coulomb's law states that like charges repel and unlike charges attract, with a force proportional to the product of the charge and inversely proportional to the square of the distance between them. Your assignment. Number 1. Count the positive and negative in each picture. Write positive charge and negative charge or no charge as it to her. That's the first diagram. and that is the second picture. Your second question, find the force between charges of 10.0 coulomb and minus 5.0 coulomb located at 200 meter apart. Take K to be equals to 9.0 times 10 to the power 9 Newton per second per meter square per coulomb. Kindly submit your assignment by sending to training@educom.ng. Thank you.